In this video, I'd like to give you an introduction to what it means when we talk about the future value of an annuity. We're first going to look at the definition of what is an annuity. We're then going to derive the formula for calculating the future value of an annuity, also known as FVA. We're then going to look at examples on how to use the formula to calculate the FVA. And lastly, another method for calculating the FVA using the interest factors. So what is an annuity? It's really nothing fancy, but simply a type of investment that involves equal amounts of money that is either deposited or withdrawn at regular intervals. We can value the annuity in terms of its future value, how much the whole investment will be worth in the future, or in terms of its present value, how much this investment is worth in today's dollars. Let's look at an example to help us better understand what it means to value an annuity in terms of its future value. We're going to consider a scenario where a regular amount of $1 is deposited at the end of each year for 4 years. The bank pays an interest rate of 1% per annum compounded annually, and we're going to need the compound interest formula for this exercise, which is FV is equal to PV times 1 plus R to the n. FV refers to the future value, the balance at the end of the investment period. PV is the present value or the initial investment. R is the interest rate per period, and N is the total number of periods. So let's begin with this table. According to our investment, we're going to be depositing $1 at the end of each year. So at the end of year 1, we're depositing our first $1. After 1 year, this $1 will grow to $1 times 1.01 using the compound interest formula, and we're going to deposit another $1 at the end of year 2. Another year passes. At the end of year 3, this first dollar will grow to $1 times 1.01 squared. The second dollar will grow to $1 times 1.01, and we're going to deposit another $1. Another year passes. By the end of year 4, our first $1 now grows to $1 times 1.01 cubed. Our second dollar will grow to $1 times 1.01 squared. The third dollar grows to $1 times 1.01, and we deposit another $1. So when we're talking about the future value of this annuity, we're essentially referring to the total amount we have at the end of year 4. So the FVA is simply equal to $1 times 1.01 cubed plus $1 times 1.01 squared plus $1 times 1.01 plus $1, and this amounts to $4.0604. So even though we invested $4, we ended up by the end of the 4th year at $4.0604. In our previous example, the calculation of our future value consisted of adding up 4 terms because we had 4 separate deposits of $1, and this was relatively easy to do. But in reality, the calculation of the FVA often involves many number of terms. For example, if someone invests equal amounts of money monthly into a retirement savings account for a total period of 30 years, the value of N would be equal to 12 times 30 or 360. And you don't really want to repeat this process 360 times with 360 terms to add up manually. But luckily, there is a formula which we can derive and use to help us simplify the process of calculating the FVA. So let's consider a general case where we're depositing a regular amount of $8, the interest rate per period is R%, and the total number of periods is N. So we're going to begin with the table. In this example, we're depositing $8 at the end of each period. So the first amount of $8 will go into N is equal to 1. After 1 period has passed, this $8 will grow to A times 1 plus R. This is using the compound interest formula, and we deposit another $8. After another period has passed, at N is equal to 3, the first $8 will grow to A times 1 plus R squared. the second $A will grow to A times 1 plus R, and we're going to add another $A. And we're going to keep on repeating this process until we get to the last period when N is equal to N, where the first A will now grow to A times 1 plus R to the N minus 1. It's been compounded N minus 1 times. The second amount, which has been compounded N minus 2 number of times, will grow to A times 1 plus R to the N minus 2. And we keep on repeating this process until the final amount of $A gets deposited. And then to calculate the FVA, what we need to do is we need to add up all these terms. So FVA is equal to A plus A times 1 plus R plus A times 1 plus R squared, so on until we get to A times 1 plus R to the N minus 1. Now, this expression for the future value of the annuity FVA is in fact a geometric series. We can first factorize out the A so that we have A outside the bracket multiplied to 1 plus 1 plus R plus 1 plus R squared all the way to 1 plus R to the N minus 1. This entire expression inside the bracket is a geometric series with the first term being equal to 1. The common ratio is 1 plus R. Since going from one term to the next, we need to multiply by 1 plus R. And in total, there are n terms. We can simplify all of this using the sum of the geometric series formula, which is Sn is equal to A, the first term, multiplied by the common ratio R raised to the power of n, which is the number of periods, minus 1, and all of this divided by R minus 1. So using this formula, we're going to simplify this entire expression. So from the second line, we're now going to get FVA is equal to A times this big expression inside the bracket, which is essentially equal to the summation. So we can see that the A here gets replaced by 1. The common ratio R gets replaced by 1 plus R. The capital N for the number of periods gets replaced by N. And when we simplify this expression, it simply reduces to A times inside the bracket 1 plus R to the N minus 1 divided by R. Now, this expression is very important. It is what we call the future value interest factor, FVIFA. So this means that our FVA formula can now be simplified to simply just A times FVIFA. So the FVIFA, remember, is this entire expression. Let's look at an example on how we can apply the formula we've just derived to calculate the future value of the annuity. For our first example, we've got Annette who invests $1,500 at the end of each year for 25 years. Interest is calculated at 10% per annum, compounded yearly. How much will Annette have in the account at the end of 25 years? This is a future value problem because we're depositing money regularly and we want to find out the sum at the end of the investment term. To start off, we need to identify the regular deposit amount of A, which is $1,500. The interest rate per period R is equal to 10% per annum, since it gets compounded yearly. And because we are investing it for 25 years, our N is going to be equal to 25. Then we use the formula we've just derived. FVA is equal to A times 1 plus R to the N minus 1 on R. And we simply sub in these values into the formula. So we're going to get FVA is equal to 1,500 times 1 plus 10% raised to the power of 25 minus 1 and then divide by 10%. Now 10% is the same as 0.1 in decimal form, so we can reduce this to this expression, and when we put into the calculator, we end up with the future value of this annuity being equal to $147,520.59. Now let's put some numbers into perspective. Annette invests $1,500 every year for 25 years. That's a total deposit of $1,500 times 25, or $37,500. But due to the effect of compounding 10% per annum, the interest she's earned is the difference between the future value of the annuity, take away the total deposits, and so the total interest she's earned was actually $110,020.59. Let's have a look at another similar example. This time we've got Jean, who invests $200 at the end of each month for 20 years. Interest is calculated at 12% per annum, compounded monthly. How much would Jean have in the account at the end of 20 years? Unlike the first question, this time we can't simply sub in the numbers directly into the formula. First, the regular deposit amount is $200. Okay. However, the interest rate given here is stated per annum, but because it is compounded monthly, we need to adjust the number. 12% per annum is equivalent to 1% per month. So our R value is going to be 1% per month. And because it gets compounded monthly for a total of 20 years, that's going to be a total of 20 times 12, which is equal to 240 months. So our end value is going to be equal to 240. Once we've got these values, we simply sub into the formula. So the FVA, which is equal to A times 1 plus R to the N minus 1 divided by R, we're going to sub A for 200, R for 1%, and N for 240. And this gives this next line. Now, 1% as decimal is 0.01. So I'm going to replace the 1% here with 0.01, and when we put this entire expression into the calculator, we get the future value of this annuity being $197,851.07. Again, let's process some numbers. For this question, our total deposits is 200 times 240, since we're doing it for 240 months. So our total deposits is 48,000. But under this type of investment, the future value was 197,851.07. So the difference is interest. So in effect, we earn an interest of $149,851.07. So this just goes to show the power of compounding. Having done all the hard work, you'd be pleased to know that there is an easy way to calculate the future value using what we call the interest factors. So some of you may have already come across these future value interest factors table. The values in each of these cells will actually derive from the FVIFA expression we found earlier. For example, if the interest rate per period is 2% and N is equal to 4, substituting into this FVIFA formula, where we replace the R with 2% and N with 4, and putting into the calculator, we get 4.1216. Now, this corresponds to R is 2%, N is equal to 4, that value 4.1216. So what about if R is equal to 5% and N is equal to 3? Again, substituting this into the FVIFA formula, replacing the R with 5%, the N gets replaced with 3. Calculating this with the calculator, we end up with 3.1525. So for R is 5%, N is equal to 3. That's the interest factor corresponding to those conditions. So let's look at how to use this interest factor table. For example, Daniel invests $150 at the end of each year for 4 years. Interest is 5% per annum. Find the future value of Daniel's investment. For this question, our regular deposit A is $150. The interest rate per period is 5% per annum. And we are investing it for 4 years, so N is equal to 4. Now, using this table, for R is 5% and N is equal to 4, that's going to correspond to the interest factor 4.1216. 4.3101. So using the formula that FVA is equal to A times FVIFA, we're going to replace the A with 150 and the FVIFA, we use 4.3101 and putting into the calculator, we're going to get $646.52. This means that with her depositing $150 for 4 years, a total of $600, she's going to grow her money to $646.52. So that's an interest of $46.52. Let's look at another example. This time, Tyrone invests $800 at the end of each quarter for 1 year. Interest is 12% per annum, and we want to find the future value of Tyrone's investment. Unlike the previous example, this time we can't simply sub in the numbers given in the question. The regular deposit is still $800, so our A is equal to 800. However, the interest rate in this question is given as 12% per annum, but we're depositing money quarterly, so we need to convert this to an equivalent quarterly interest rate. Since there are 4 quarters in a year, we're going to divide 12 by 4 to get an equivalent interest rate of 3% per quarter, so that our R is equal to 3%. We're investing it for 1 year, but there are 4 quarters in a year, so our N should be equal to 4. Now we're going to identify the FVIFA corresponding to 3% interest and 4 periods, and this is going to be the number 4.1836, 3%, 4 periods. So now using the formula FVA is equal to A times FVIFA, we replace the A with 800. The FVIFA gets replaced by 4.1836. So we have 800 times 4.1836. Put this into the calculator. The future value of the investment is $3,346.88. So to sum up what we learned in this video, we learned that an annuity is an investment that involves regular deposits or withdrawals. In this video, we focus on the future value of the annuity. This is when we're valuing the value of the investment at the end of the period. And we learned that the FVA can be calculated using the formula FVA is equal to A times 1 plus R to the N minus 1 or divided by R, or using the interest factors. In our next video, we're going to continue on and we're going to look at the present value of the annuity. Thanks everyone for watching the video. I hope you guys enjoy that. If you benefited from it, please give it a thumbs up and don't forget to subscribe. We hope to see you all in the next video. Bye for now.